Okay, so I was saying the nail, we are not going to use more column for the nail. Reason being, we don't have the cohesion and friction angle. So we just, for nail, we model it as elastic.
Okay.
So that's where we clicked on elastic. Now we can enter the elastic modulus, which is 0.8, like this. Then the Poisson's ratio is 0.24. Then we can go to the porous. Do we need anything here? Nothing. So you just have to put elastic modulus and also the Poisson's ratio, then the unit weight. So that is the dry unit weight, which is 77. So you put it there. So you also have to be very careful with the unit weight that you put, because it's the one which controls that self-weight thing in the model. The one which you saw, the one which is pointing down. Okay, let me just save it here. Okay, when you are dealing with Midas, like there are very many files which will be created, so you'll just be seeing them. So meaning that there are many. If I try save, we will see there are many files. We will see them later. Okay, so now I have saved. So I think these are other things, you leave them as default. There is time I asked those Midas people and they told me that other things, if I'm not working with them, you just leave them as default. Okay, so now we have defined all our materials. We have foundation, we have embankment, you have nail. So now we can close. As I told you, you just follow the order. So the next thing is property. If we can remember, we said there is 1D, 2D, 3D. So all our properties are for embankment and foundation, they are 2D. So this is foundation. You click OK. Okay, we can click apply. Then the next one is embankment.
What is that material sign? CSYS.
Where is it? This one.
Left hand side.
Left?
No. In the window. In the
Where?
2D property window, there is a
Yeah.
tick. There's a tick, right? See.
This one. This one.
Oh, that one.
You go and touch there.
What is this?
Coordinate system.
Oh.
Coordinate system. I'll show it to you when we finish meshing. It's the coordinate system. But this one, you just don't touch on it. You just touch on it when you finished meshing. You can see that all the coordinate systems are going in the same direction. If your arrow is like this one, the way you are seeing this green one is facing up, the red one is facing this side. So when you finish meshing, you should make sure that all these coordinate systems are in the same direction. Yeah, you can just check it when you are after meshing. So now this one is okay. I've finished. One more thing you have to check here. You have to click on this arrow and go to embankment. The first one I clicked on foundation. So this one is embankment. Then you click OK. So the next is this one, the element, which is nail. Then you click OK. Oh, Do you know the reason as to why it's not? Because error, property number, description, area 0. A nail cannot have 0 area. So what you have to do, you need to check here, section. And our nail is not rectangle. It's what? It's a circle. So you come here and put there solid, round. Which size should we give it? 50 millimeters. You just give a 50 millimeter nail, which is around 0.05 meters. Okay? So this is the dimension of the nail which you want to put in the soil.
50 millimeters is big. It's big.
50 millimeter, not meters. 50 millimeter.
Nails means like very small.
A nail which you just put in the soil.
Okay.
Yeah. It's a reinforcement thing. So
Okay.
now you click OK. Now you can see everything is now there. They are auto calculated. So you can click OK. So all the properties have been created. So the next part is about assigning meshes. We are going to the next step, which is meshing. So when you want to assign mesh, we come here. Like here you can see 2D, 1D, 3D. So you click on 2D because our problem is 2D. Now you can see here the size of the mesh. When you reach here, you don't click on auto face. Auto face, use it when you are dealing with 3D. Here we are going to use auto area because we are dealing with a 2D problem. So now the mesh size, let me first make it 1. If at all I find out that it's okay, I make it 1.5. If it doesn't, I will just try to increase. So now I just select embankment. Oh, this is for embankment. This one I unselect it. So if this, I just select the whole of it like this. I'm also going to take the nails there because they're also embedded in the soil. Okay, so I have given it 1.5. I click apply. One more thing, sorry. We need to check the high order. High order is very important. High order element. We saw in order to increase on the accuracy, you need to check the high order. You check it from here. These are the things you check. This one, high order element. You check it, then you click OK.
What does that mean?
High order, like you are getting the, these are partial differential equations. So if we go with high order, you are improving the accuracy of the model.
So do we need to do that for all machine?
The moment you are clicking on apply, that means it will take into account all other things that you are going to model. But if we're not, for example, if I do OK here and I finish, if I want to model the second part, I need to go again to higher order. But if I'm doing apply, it will affect all other things that I want to do. So that's why it's advisable to always use apply. Okay, so now let me just start afresh. Auto embankment. Like this. Then the mesh size, let me make it 1.5. 3.2 looks to be big, very big. Then I can just select then I go to higher order element, I click OK, I click apply. So now if I click apply, meaning that I don't need, if at all I want to go to something else, I don't need to put it there. So now the next one is foundation. When I'm on foundation, this one has to change to foundation. I also use the same mesh size. Then I click on apply. There is no selected object, so you have to select, okay? If you don't select, then that means you will not mesh. I select this, 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 and this. So this is our foundation. I click apply. Okay. So now that means the other order element is also taken into account. Then remember here we have nails. We also need to change the kind of meshing. When you want to deal with nails, there is what we call extract. I don't know how we're going to get it here because it's somewhere here. Okay, let me just get it from here. This is extract. When we want to extract, we are going to extract only nails. 1, 2, 3, 4, 5, 6, 7. Okay, there are 8 nails, so we just extract them and write nails. Okay, so now we are done with the meshing part. The meshing part is done. So the next stage, the next step which we do is called loading. Boundary condition or loading. We can apply boundary conditions or we can apply loading conditions still. We can just do in any order that you want. So you come to static or slope analysis, and as I told you, the different boundary conditions. This is the self-weight. If I click on self-weight here like this, you will see that since this is a 2D, the thing is on the vertical. This GY will be -1, meaning that it's going downwards vertically. So I'm putting that self-weight. Remember, we had the default self-weight. So if I want, I can put mine there, or if I want, I don't put it there. Still, it doesn't. Because when I go to the stages, construction stages, I can either select this one or I select the other default. It doesn't matter. This one, I'm just simply putting it there because I want to show you how you can put in case, because there are some versions of Midas where they don't have this default default self-weight. The default is in the latest versions. So I can just call it self-weight like this. Anyway, we are going to see the details later. Okay, so now you can see when you
assign self-weight, default means like the program calculate the self-weight of all elements.
yeah, the whole thing, the whole model.
So
Yeah.
when we are loading, we can ignore the self-weight.
No, it has to be there. Like everything is, it
No,
has its
no,
own
like
self-weight.
when we apply an external load, then we can ignore the self-weight and apply.
You know, I think you are not supposed to ignore self-weight. That one is already there in any zero mass. There is self-weight. You cannot say that. Even if you want to apply another load, then the self-weight is also supposed to be there.
Okay.
You can apply your load, but the self-weight is already there.
So you're adding both of them.
Yeah. the self weight is already there.
Okay.
Yeah, because you cannot even. Now, assuming that this is the soil, you are applying some force on it. Does it mean that you have taken the weight which was in it? So that's why you need to keep the self weight inside. Okay. So this is the first boundary condition, the loading. Okay. Then the boundary condition, you can check where there is constraint. Constraint is where you apply the boundary conditions. So if you can check here, they will show basic, advanced, auto. So this depends on the degree of freedom that you want to assign. But I always prefer using auto because this I will not do any other thing or just simply click on auto. They'll just put themselves the way they want them. So this is ground boundary. So if I click it there, now you can see. So if I maybe enlarge, you will see on bottom. This means that the bottom is fixed, fully fixed. They are restricted to movement in both directions. Then if you go to this one, lateral, you will find out that these ones are like, this is how they appear. They are different from the one which are bottom, meaning that it can just move. Yeah.
Okay, about the boundary conditions. If there is a water level, then do we need to make the lateral boundaries to restrict water drainage? You understand what I'm saying?
Yes. Actually, that's one of the questions they also asked. Again, asked me about it. Yeah, like now when we put this kind of boundary conditions, do they also apply to water?
No, it is just movings, right?
Yes, it's about movement.
Movements,
Yes.
right? Not about
Not
water.
about water.
So that means this kind of boundary means the water can go freely, right?
Yes,
but
yes.
in real conditions, it is not
It's
like that.
yeah.
Yeah.
So-
So how we can simulate real conditions?
So if we want to put water, the water level, that's why we define water level. There is where we can define water level. Assuming that I have drawn something here, for example, geometry, I put there a line somewhere. Okay, maybe let me just put water level here and see what will happen. Water level, where is it? Okay, analysis, water level. Interval. Do we need to put interval? Does it mean that it's assigned here? No, we cannot see it. Water level.
You remember I also tried that, but
It didn't work.
Yes.
There is no selected object. Wait, let me see this one. The mesh generated from Midas. Why is it not working? I think you apply it when you go to the, let's see, when you go to the nicest case, maybe there is where there is water level. I saw something like that. We will try it there. Okay, let me first undo general function. Yeah, because whatever, I think it has a function which will also follow.
Yes.
Okay. Add support. Okay, so now we can proceed with this. Okay. This is where we had reached. So now we have already applied the boundary conditions and the loading conditions. One more thing which I said about checking the mesh. There is where we can check the CSS. I think it's this one. I'm not sure. Okay, maybe it's this. Not this one. Show all the elements. Aha, this is the one. So you have to check whether they are following the same directions. This one is like this. So you go to your coordinate system. Where is the coordinate system? Where is it?
Is this like local coordinate?
Yeah, this is global coordinate.
Local, this is, okay.
So you have to make sure that it's supposed they're in the same directions. You have to always check that.
Why is that important?
Yeah, eh?
Why is that
That
important?
it affects, like when you are modeling, it affects you, like when sometimes when you're modeling you find out that some errors are found out. So in order to avoid those kind of errors, you have to check that all these things are like in the same direction.
Though in this case, they are not in the same direction.
Yeah.
What?
Then some of them are going this way, some others are going this way.
Yeah, this is called local coordinates. And local coordinates are specific to that specific object.
Yes. So
Right? Global means global coordinates means the coordinates are same to entire
Model.
model. Like x, y, z are global coordinates. These local coordinates are different.
so you have to come here and just make sure that they are going in the same direction. I'm not remembering how I do it, but somewhere you have to, like when you are doing it, you check, when you check and find out that they are moving in different directions, there is somewhere among these functions, I don't remember where, what you do, you just click on one of them which is in the right direction, you click on it, after clicking on it, then you can just assign all others. You select the whole model, then you assign to the right direction, then that means they all move in the same direction. But here I cannot remember exactly where we click. So let's just go with the way it is and see if we don't get errors. Actually it's about minimizing errors. At times you can even ignore and you just get things which are okay. Okay. So now I have just ignored it. Under normal circumstances, they were supposed to be this is how they're supposed to be. Okay, so now we have already finished loading. What's the next stage? After loading, boundary condition, the next step is what? Creating cases. So come to analysis. In this model, let me just apply rainfall. That's another boundary condition. You asked about the review boundary. This is how we can apply it. For review boundary is part of seepage and consolidation. So when you look at this, you will find this review is already there. And I want seepage along this on the edge of the model. So if I click here and I change to edge, Then this is, I call it review. Review. So now I can select the edge.
Is it working? Is it working?
Yes, it is working.
Okay. So whenever you have things regarding seepage, always select review boundary. So I have already finished, then I can click OK. So now you can see, when you see this, this is an indication that you already selected these ones which are appearing there, the blue things. Then rainfall. If I want to apply, maybe I'm assuming that it rained, like we got rain of around 50 millimeters per day, or heavy rain of 250, I can come to surface flux. Then here you can allocate the rainfall. So this is in meters cubed, and I want to use millimeter, maybe 50 millimeters per day. Let me just put it in millimeters per day, because I don't want to do the computation of putting it in meters per second. Okay, so I use rainfall of 50. Which rain should I use? Should I use high rainfall or low intensity rain? I use heavy.
Use heavy.
Okay, let me use like 200 millimeters cubed per day. Millimeters per day. This actually this one will be cancelling with each other, so I'm using 200. Then here you can just, when you are applying rainfall, you apply on the surface. On the surface. So now I can select where I want to apply rainfall. This one. This. I'm selecting where I'm going to apply rainfall. Okay, so when you finish, you can now see it's 200. Now I write the rainfall. Then okay. So now you can see this is rainfall. It's already applied. So now the next, okay, now let me also tell you if you want to introduce interface, if you want, but here we are not going to use interface.
Okay. Before moving to interface,
Yeah.
for the boundary conditions,
Hmm.
we have already applied whatever, right? Whatever the previous question I asked, how
Hmm.
do we, how can we restrict water flowing?
Water flowing.
Water flowing, like two sides of the boundaries.
Yeah, actually, according to what, that's the same question Ajan also asked me. But we tried to look at all the cases where they were analyzing. They just don't consider that aspect. They just assume that they don't restrict it. Like,
That means you have model a large
They
soil
will ask you
mass,
this
right?
question in your final answer.
And then we need to model a large soil mass, right?
yes. Yeah, so maybe if it's a large soil mass, you just don't consider it. So this is how it is.
But it affects if we don't do that in the bottom boundary, right? Because the water is
Just
flowing,
mhm.
yes, then the conservation settlement will be significant more than the normal conditions, right?
assuming that the thing is maybe the soil is porous, is having like is not, it's not clay.
Oh, maybe we can define some another material from the bottom,
Assign another material like
a
what?
rock.
We put a rock. Maybe if it's clay, but still if it's also clay, that means water will not even be moving very fast. Okay, so what else do we need? We have already put rainfall. The next stage is creating construction stage. We are going to have different construction stages. Here we come to stage set, add construction. So now we are going to use semi-coupled analysis where we can get stress and we can also get seepage at the same place. So here you come to stress seepage slope. I forgot to write its name here, so let me just remove and I rename it as slope stability. So it's stress seepage. So now I'm just using coupled analysis. There is seepage and there is also stress. I add. Okay. After adding, you click here, define construction stage. So I'm assuming the first stage, maybe I just extend this one so that you can see what is going to be happening. So if you want to see what's happening, you just come here to activate. So now I have not activated anything. So let me make my initial stage as stress, initial stress, meaning that here I'm only considering self-weight. Initial.
Before rain.
Hmm?
Before rain.
Yeah, before rain. I'm considering initial stress before it rains. Initial stress. So if it's initial stress, that means here you just activate stress. And what do you need to activate? You activate embankment, foundation, and you also activate ground boundary. Then you activate. Now, I told you about self-weight. You can see here we have two self-weights. So you can choose any. So if you want, you can choose default. If you want, you can choose self, this one which I created. So let me just choose the one which I created. So that means it's the one which will be considered in the analysis. So now these are the things which I have activated under the first construction stage. So remember, in the first stage, we want to compute factor of safety. So you click on slope stability. This SRM means strength reduction method. That is based on a C5, more column. We are going to reduce the strength of the soil until failure occurs. That's what this method means. So you always use strength reduction method. You try to keep on reducing the slope, the strength parameters until the slope fails.
That is only for slopes, right?
Yeah, it's only for slopes. If at all you want to calculate factor of safety, actually it's not only on slopes. In other things, if you want to calculate factor of safety, you cannot compute factor safety in other things, embankment, slope. So, okay. So this is when you want to understand about factor of safety. Maybe if I can show you the method, how it works. Did I talk about it here? In my thesis, I talked about this strength reduction method, how it works. This is how it works. So here you can have the initial cohesion, then you also have the trial for factor of safety. You keep trying, so it's like based on trials. But for this Midas, we are lucky it is done automatically. I first tried using it in Abacus. When I was doing it, I first did it manually. You just do it in Excel sheet, like that.
Do we need to do that for the foundations as well?
I'm not sure. So this is how you can do it. So this is the first stage. Then another thing here, you have to check clear displacement. What does this mean? It means that we are just resetting. It's like when you want to start running, for example, and you want to know like the kind of minutes you are going to take while running. If you are using a stopwatch, you have to first reset it to 0. So this is what it's also about. You have to clear displacement before you start. Okay? So now you save. I'm saving the first construction stage. After saving, you click on new. Now my second construction stage is going to be based on seepage. It's where I'm going to consider seepage. So this one, you call it transient. The one which involves seepage is called transient stage, and here I call it transient. So remember, when you are dealing with seepage, there is time step. You have to define time step. So you click on time step, and I'm assuming that it's going to rain for the whole day, which means I can put there 1 day. So if it's 1 day, you also need to understand at what time we're going to be getting the results. You can also define this. Maybe let me just again change it to,
like how many times?
actually not about times, at which stage or which step I'm going to be getting the results. If maybe I consider 1 day, which is having 24 hours, I can decide that every 1 hour I check the results. Another hour I check another result. Like that. So I think let me just first I change it to seconds to the other. It's when I will define it better. I go to meters. This is meters. And then this one is seconds. Then time step. So how many seconds are in a day? 3,000.
3,006.
No,
600
that is
divided
in
by
one.
24.
Yeah, which is 86400. 86400. So these are the number of, so I just get 24 steps.
These are the number of seconds in a day.
Yeah,
Should be more than this.
you calculate.
That means
Calculate, it's 3,600 times 24.
that means I didn't get it.
That's true. 60 times 60 times 1 times 24.
Yeah. What? You're forgetting the question.
No, not for multiplication. You said the duration for 1 day. Why you put 24? That means you take readings every hour.
Yeah.
Okay.
Yeah, that's what it means. So I can check like displacement or other things, other results
That
after.
thing didn't process in my head.
So this I do, if I do like
this,
this,
it's 1 day, not too much for real life situations.
of
How
course,
about if you put,
yeah, it cannot rain the whole day.
8 hours.
Yeah.
Then you now
Mm-mm.
put it at 1 hour interval.
Yeah.
That means
Yes.
if I do it for 1 year, it would be 365 days,
times.
uh,
So
and-
actually, this one you set it by yourself. This step number you can not necessarily putting 24. If I want, I can even put 3. So here you define it by yourself. Sometimes you can even check 24, or then you even go to directly to the last. Yeah. So if I just click here, I can click on generate. So now you can see 1 hour, 2 hours, 3 hours until you go to the last one. So you click on OK. But remember, now it's transient. You have to activate rainfall and review boundary. Rainfall and review boundary. You activate them. So if I activate now, you can see they have gone there. Remember, the first one, since this is like corporate analysis, the first things which were there are already there. The first step, the first construction stage. So this is the second one. I don't need to activate again embankment and foundation. So I can click on OK. I've already finished. Then the next stage, I create another one which is called stress, because now I want to check factor of safety after rainfall. So this one I call it SRM, post-rain. So now I want to check the stability of the soil when it has rained. So again here, you need to check this slope stability. Here I want to compute, but here will not again clear because it's continuous. So
we put that clear displacement only at the first
when
construction
you are
stage.
starting here.
Yeah, that is important.
That's an initial stress.
Yes. At the initial stress, it's where you just check it. So now I have checked it. Okay, so now since it has rained, we expect factor of safety to reduce, isn't it? We act like when the slope was stable, it might be stable. Like that's common with unsaturated soils. Like the soil which is unsaturated may appear very strong, but the moment it gets in touch with water, it becomes terrible. So that's why we are expecting here that maybe the factor of safety is going to reduce. So now we can introduce the nail. So our next stage is introducing nail.
Yes. But you didn't save the last one.
I did not save?
You did not save.
Really? It's already saved, this one, SRM post-rain. It's already saved. So now this one is going to be SRM nail. Here I have put nail, so I have to activate the nails. So they have gone there. Now I have to check slope stability. So now I have already finished my construction stages. So if we come here to analysis and we click here, you find out that these are the things which we defined. Okay, one more thing here. If we check edit, here you can actually edit at any stage. You can keep editing the way you want them to be. So for example, if I click on analysis control, you will find different other things here. You will find nonlinear. For example, I want to get results every after increment, and I want like 10 increments or 5. Let me see what is going to happen when we are calculating. Anyway, these ones are not very important. What's important is just getting the final factor of safety. But if you want, you can still consider this. Okay, so this is done. Now we have already finished construction stage. The next stage is analysis. So when you click on analysis case, you can right click and say add. Add, this is so stability trial. So now you come here and go to construction stage because that's what you have considered. Then there are also these other things, analysis settings. This is where you asked about the core value, which I also haven't understood. I forgot, they explained it to me, but I don't remember. But when you click here on initial stage for stress analysis, this is our initial stage, which we started with. Then these other things, you just leave them the way they are as default, but you also have to click on clear strain. Then you click OK. And OK. Output, these are the outputs which you are going to get. All these things you can get them: displacement, applied load, reaction, seepage, temperature, strain. So these are the outputs. So you click on OK. So now we have finished creating the analysis case. Let me again check to be sure whether I checked the slope stability here. Yeah, it's already checked. Let me see here whether I checked it. It's already checked. So now the next stage is running. So if you want to run, you click here and solve. So these are the partial equations which are going to be solved. So it's now solving. Okay, excuse me, let me just take a rest. When you sit for long, it's always good to stand up and take a short break. Okay. Yeah, you also stand up for a moment, refresh.
You understand what he's doing. I see you're asking questions.
Yeah, that is because I did that. I did that before this workshop.
Okay, you watch some videos.
Yeah, I already
You already used the app.
developed
Some
some
things.
models,
Okay.
like foundations, and I encountered those issues. And I checked with ChatGPT and tried to solve those issues, but did not work.
ChatGPT is not answering you.
No, those things are a bit complicated for
Okay.
ChatGPT.
So on YouTube there are no videos like this.
Hmm?
Are there videos on YouTube?
Actually, what he is explaining is very important. And if you are doing a slow
No, not YouTube. On the road.
road, then there are YouTube videos. I saw there are some sort of things like
Road.
videos. But then we need the way he is running program and the way he is assigning and all the
Yeah,
things are
It's
similar.
very important.
But there are different specific things. Road and analysis for
Has
foundation.
already finished running.
What?
Is it still running or finished? Finished.
Still running.
Huh?
It's
It's already finished running.
already, no, it is, yeah, it is, yeah, because the model has locked, right? You have to unlock that.
Is there anyone who pressed anywhere? Did you press anywhere?
No, we didn't press it.
Is there anyone who tampered with my thing?
What just happened? No results.
It stopped.
It stopped?
Maybe you can click this.
Error.
Unlock,
Cannot.
Cannot
Okay.
scratch file. It sent an error message.
unlock the model.
No, this one is showing. Actually, let me see. Error. Cannot open scratch file. Tamas at University Slope Model. Try.
That means you are not saved it properly, is it?
I don't know what happened. Cannot open scratch file. Did I save it well? Let me see. Okay. Let me just run it again. So cannot. Cannot.
Maybe you try to save it first again.
This one. Save. Why is it taking long to even save?
Not save.
Wait. Save as.
Maybe save as another file.
Yes.
If that file is not found. Oh, you need to put
Why is it
GTS. No.
Why is it showing NX GTS yet I had saved it at first? Okay. Let me say. Then we run now. So
Not working.
still the same. Analysis data is transferred, solve successful error. Cannot open scratch file. OneDrive. Is it about the location? Is it about the location where we are saving it? Let me save maybe different location.
It is about the location, right?
I think
Simultaneously training.
let me save
Maybe in the desktop.
in local disk D. New folder. This one. Okay, then let me see solve.
No, it's
It was about the location. The location. So this is factor of safety. You can see maximum displacement is factor of safety. So that means when you're also doing routes, don't save on that location. You have to create a folder on local disk D. Yeah.
I don't know anything about this factor of safety.
Hmm?
I don't know anything about this factor of
The-
safety.
But even in structure, you know about factor of safety.
Yes.
Yeah.
I have to find it out.
But you know about displacement.
Mm.
Yeah. So now it's this is the factor of safety. The initial, this is how it was. Then after rain, like initially it was 1.4 something, around 1.5. Then after rain, it reduced a bit. Then when we installed nails, it increased. So now it has finished running. This is just a simple model. That's why it has finished running very fast. Yeah, if I told it's like you're having some other things, the way I had porous concrete, the way I was putting interface, it can take some time when it's running. And also another thing, the size of the mesh. If I told you have very fine mesh, then it will take time to finish running because there are partial differential equations which are being solved. Yeah, so if you have fine meshes, there are very many equations which are being solved. Okay, so now we can just go to the next part, which is checking the results. So now these are the results already, but now we go here. So if I want, I can just close this one. In a linear graph, I can just close it. So the moment you see it in this format, it means it's ready. I have already finished. So if I click here and I want to do some other things, I can now add another things. I have locked it. If I want, I can go to geometry and create some other things here. Then if I want again to check things, the finished run, the model which you have run, I can come here and unlock it. So these are the results. You can see the factor of safety. Initially, the factor of safety was 1.5. When it rained, it reduced to 1.4. Then when we installed nails, it increased to 1.58. So this is how you can these are the values which you can use if at all you are predicting the stability of slope after installing the nail. So if you want, you can also change the location of the nail, or you change the length and see the variation. So that's about factor of safety. If you want to check things regarding with seepage, you come here to transient, the first stage, the first time step. This is after 1 hour. So you can monitor total head, you can monitor pore pressure, you can check the phreatic phase. You see, this is where the phreatic phase is. Then other things which you need to know is about the pore pressure. So you can find out that the pore pressure is here at the bottom. It's where you have too much pore water pressure. So when it's raining, water keeps infiltrating slowly, then it will just build up at the bottom. So one more thing that you also need to know, you can understand results at different locations. There is this probe. When you click on it and you go to any point like this, so you can see the results. Also, you can just, I don't know where you can see the maximum and minimum. Value. So when you click on value, you can see minimum and maximum. So this is negative, where there is negative pore water pressure. And these are you can just check the results from here. If I want to exaggerate so that they can be seen very well, these red things, so you can just right click and you say auto range. So this is how you can see the results. Then this is about pore water pressure, and if you want to see about displacements, you come here in the first stage. I'm still looking at the the stage where there is before rain, the initial stress. So if we go to displacements here, this is total displacement. You can see much stress, much displacement is here around the toe of the slope. So there is too much displacement. That's total displacement. Then displacement in the x direction, this is how it appears. Then there is one more important thing which is called, how do they call it? The slip surface. Slip surface, you can find it here on, is it on plane strain? No, it's on strain. E effective, where is it? E maximum shear stress. So this is how you can get the slip surface, this one. So that is before rain. Then after rain, post rain.
Is it the failure?
Yeah, this is the failure line. Like, it's not failure, but the failure is expected along this. This is the weak plane. So, if you can remember when I was going to rainfall, after inputting things regarding rainfall, there is something that I did. Like, I went to analysis and I increased, where I said every increment. This is what I put 5, so you can see 1, 2, 3, 4, 5. These are the ones which I was putting there. So you can check displacement also here. This is after rain. Total displacement. Oh, I think it's supposed to be at, we can get the values when you go to this location here. Displacement, like this. Okay, so these are the displacements. So after rain, you can see the displacement is too much, and even the slip surface changed a bit. Let's go to the plane strain. By the way, you can also understand about shear forces, bending moments, because you have nails here. You can check on the truss elements. See, torsion. So these are the main results which you can just view from this. Then there is a way you can also create tables or graphs where this one is I have to minimize a bit so that, because the result tab is here, this thing is hiding it. Yeah, it's hiding it. Can we move it somehow? This one you cannot move it. But when you are on results, there is where you can click. Maybe I'll just show you when you're in the graduate tool. This one is not showing. But basically, these are the major results which you need to know. Displacement, factor of safety, slip surface, water pressure buildups. So this is about the slope. Then if we're dealing with foundation, settlement, consolidation, I think maybe you can again check some literature and find out. But maybe I can also try to see the things which we're doing. I can try to find out and tell you, yeah, if we have some questions regarding that. But you need to first make some trial. So you also need to make use of this probe tool, this probe. So you can keep checking the results at different locations here. Now it's -20. If I click here, I can see what the results are. Another thing you can also check on the manual. Everything is there. Whatever kind of analysis that you want to do, you will find it there. Is it on desktop? I think we saved it on desktop. This one. So it's having most of the analysis which are done. Yeah. So you can just find the details here. Only that you cannot read the whole of it. It's around 570 pages. You just go straight to what you want. If you want to understand about elastic modulus, you can write elastic and search. You see where it is. You just read through it. Then I said that I also talk briefly about interface. Maybe we may need something regarding interface. Assuming that you have materials which are having contrasting properties. One is having high permeability, another one is having low permeability. So you just go to where there is interface. It's also here. I can see it. It's somewhere here.
It's okay.
Yeah, so you just go to interface, and when you are defining interface parameters, there is what we call normal stiffness and shear stiffness. So those are defined based on more column also. So you try to get the materials from the adjacent layer. For example, if the interface is between soil and concrete, you can use the material properties of soil, but there are some equations that you use.
I think there might be literatures which is showing those parameters related to the interfaces.
Exactly, they are there in literature. Even in
Because
this,
I did my bachelor's research was interface parameters.
yes, so the interface, these are the equations which I used. Let me show them to you.
So only for the concrete soil interface.
Yeah,
right?
concrete soil
Not
interface.
for the soil layer.
Not soil, yeah, because we think that for soils to soil, there is no much differences. So this is, yeah, so this is how you find the shear stiffness. Then this is the cohesion of interface. This is the equation that you use. This is the phi for the interface. So these are the equations which you can use. And if we're also dealing with unsaturated parameters, these are some of the equations that you need to solve. Yeah. Okay, so you go for lunch. Any question? Yeah, I'm still here. In case of any problems, you can just ask. Still, we can keep discussing. If I don't know, I can also try to make research. I can try to make research. Maybe I can also add on more knowledge. Yeah, because I'm also new in this thing. I started learning it. Was it in May? It's when I did some significant things. Yeah. Okay, thank you for listening to me. That's the end of it. Okay.
Actually, this is thank you very much.
So now the important thing is just understanding the basics. As you understand the basics, other things you can keep exploring them. Yeah. And the good thing with Midas team, they're helpful. In case you are lost somewhere and you send them a message, they respond immediately. Yeah. Okay, so now we can just stop the lecture.
Okay, this is all for today, right?
Yeah, this is all for today.
Are we continuing there?
Eh?
Are we continuing the graduate room?
Yeah, if you want, you can just check something.
I'm saturated.
Oh, yeah, like the other student last time. Okay.
In the lab.
What?
In the lab, when I was teaching about consolidation, I told them that, oh, there's something which I also need to explain. I said, okay. That's how they said.
They say it's okay for today.
Okay.
Yeah. Anyway, in actually understanding things, you also need to understand the theory behind. Yeah, you need to first read the theory. After understanding it, the reason as to I'm not used to the things of water level, I have not been considering it. Reason being, for my slope, I assumed everything to be unsaturated.
But in my case, that is the most important.
It's most important water
Saturated
level.
soil and
Yeah.
consolidation, water
Yeah.
pressure and how it behaves is so important.
It's very important.
And you're dealing with foundations.
Yeah, it is not about foundation. Since I'm doing consolidation, the how the water flows is
Mhm.
very important because that's the point of consolidation.
So you can also maybe check the hardening model and see, because they say that the one which gives accurate results when you're dealing with such cases.
But I asked you about the question about the boundaries, right?
Boundary condition.
If there is no function to change that, I'm afraid it is possible for me to do this consolidation. You understand what I'm saying?
Yeah. Yeah, maybe there is something there. But I asked them actually, let me show you. I asked them that question, the Midas people. I drew the slope. After drawing it, then I asked them that which kind of boundary condition to assign here. Yeah. Let me show you how the question was.
Who asked that question?
Me.
No, like about the boundary condition.
It's a journal.
It's a-
Yeah.
it's a-
When we are having a discussion. If we have different layers, yeah.
Yes.
It's fashion.
Yes.
Okay. Midas. Let me see the kind of response they gave me. I remember they responded me about that boundary condition thing. It's this one. You see, I just showed them. I even drew this, then I showed them lateral. I'm seeking clarification on how to progress and flow boundary conditions in Midas. So far, I have defined surface flux at the top, boundary to simulate 24
What
and
was
review.
the answer?
Let me go to the answer, how they answered. My question is, do we need to assign additional flow boundaries such as inflow, outflow, impermeable condition at the bottom boundary? If the realistic problem represents the lateral and bottom side as drained boundaries, then you need to give the review boundary S. No need. The review boundary, which the other one which you provided, no need to define them as impermeable boundary. That's what they said. No need to define them as impermeable.
So is there a function to define a boundary impermeable or permeable in the Midas?
No. But for the flow, there are some functions for the flow. I saw there are many functions for the flow. If I open here, where did I see flow functions on the C page? Where is it on? You see here, there is some functions. This one. But I haven't worked on it. You see, these are the functions, the flow functions. Yeah. So I don't know how you can deal with it.
Seepage means permeability?
No, seepage, flow of water. Yeah. Yeah, but if you have any technical question regarding foundation, you just write them for me. I will ask them.
Okay.
In case you have any question that you think that it needs to be addressed regarding your project.
That effect can be minimized if we
Have
put a
different
large
layers.
soil mass
If-
and different layers
Mhm.
and consider only the top section.
So whichever question you think is very critical, just write it well in a good way, the way you have seen I've been writing the questions, then you just give them to me. Now I have contacts for most of them because they want even like to have memorandum of association with my university, so they just keep even contacting me, asking me things. Yeah. So if any question, I can just ask them and they will respond. Okay. That's all I prepare for after lunch
Yeah, yeah.
meeting.
Like which time?
That's true.
1 or 1:30? You said 1. What time did you say? I think it's 1:30. OS again, he comes at 1.
For you.
Thank you very much.
You're welcome.
Thank you very much
Because
for your time.
if we had to find it out from our own, it takes like 1 or 2 weeks.
Takes
Yeah.
1 month. Okay, let me stop the video.
Hey, it's still taking the video.
Yes.